All right, so data encoding. It's one of those things that sounds maybe a little bit dry at first, but it's really important.
Oh,
And especially if you are, gunning for those senior software engineer roles, this is really bedrock stuff.
absolutely.
And
Yeah, it really is.
how we choose to represent our data. I mean, it impacts everything. It impacts how well our system performs. It impacts how different parts of our architecture can talk to each other.
For sure. For sure. Um, and I think it's one of those things that, really can help people stand out in interviews,
Yeah.
when they're going for these senior level roles, because you're really demonstrating a deeper understanding of the systems that you're working with.
Right. And it shows you're not just a coder.
Right.
You're an engineer. You're a senior engineer.
Exactly. Yeah, you're thinking about the bigger picture,
Exactly.
not just, how to write the code,
Yeah.
but the implications of those choices.
Right. And so when we think about, kind of standard ways to encode data, I mean, the big three that kind of come to mind are JSON, XML, and CSV. And you see those, everywhere.
Yeah, they're everywhere.
I mean, they're supported in every language, every platform pretty much.
Yeah, ubiquitous formats for sure.
Mhm.
I mean, XML has been around forever. Um, I think very powerful, very flexible, but sometimes to its detriment.
Yeah.
A little bit verbose maybe sometimes.
Yeah, a little chatty.
Yeah, with all the tags.
Yeah.
Um, and then JSON came along kind of as a, response to that in a way.
Yeah.
Much more lightweight, particularly suited to the web and JavaScript.
Yeah.
And then CSV, the old reliable for
Yeah.
just tabular data.
Yeah.
Maybe not as powerful, but, simple to work with.
Yeah, and I think, we all kind of use these things and we kind of take them for granted, but they're not without their downsides.
No, they're not.
Okay.
I mean, yeah, we were just talking about XML's verbosity.
Yeah.
I think that's a common complaint.
All those closing and opening tags, they add up. You know what I mean?
Yeah, for sure.
And then even JSON, for as simple as it is compared to XML, I think under the hood there are some kind of interesting limitations there.
Yeah. And this is where things get a little bit nuanced because, these are text-based formats, and so they're meant to be readable to humans, although that's sometimes debatable,
Right.
the actual syntax.
Right.
But, they introduce some ambiguities and some inefficiencies potentially. So just as a simple example, like if we're talking about numbers,
Yeah. Yeah.
if you're looking at an XML file or a CSV file and you see just a string of digits,
Right.
how do you know if that's actually meant to be a number versus just the characters 1, 2, 3?
Right, a string. So like 1, 2, 3 in a CSV, is that an integer? Is it a string? You don't really know.
Right, exactly.
You need some context outside of that
Right.
to know for sure. Now, JSON, at least, it makes a distinction between strings and numbers.
Yeah.
But even then, it doesn't make a distinction between, say whole numbers and decimals.
Right, right.
And it also doesn't specify the precision of those numbers. So
Yeah, and this can lead to some really subtle problems, particularly if you're dealing with very large numbers. So you can imagine like, a system that has a unique ID that's a 64-bit integer.
right.
If you're trying to parse that, using a JSON parser in certain languages, it might default to using floating point numbers.
Yeah.
And so you might actually lose precision there.
Interesting.
Yeah, and this is why sometimes if you look at APIs, like Twitter's API for tweet IDs, they'll actually send the same ID twice. They'll send it as a number and as a string.
Really?
Just to kind of circumvent this problem.
Oh, wow.
Yeah, it's a
Oh,
workaround for
very-
an inherent limitation.
So it's like putting a Band-Aid on it, basically.
Yeah, exactly.
And it's not just numbers. What if we need to represent raw binary data? Like an image or, a compressed file or something.
Right.
I mean, JSON and XML, they're not really meant for that, are they?
No, they're fundamentally text-based. And so the way that is usually handled is by encoding that binary data into a text format like base64.
Right.
And so it works. But the problem is that it increases the size of that data
Right.
by about 33%.
Wow.
So you can imagine if you have, a lot of binary content that you're sending around, it becomes pretty inefficient from a storage perspective and a transmission perspective.
Wow, that's a huge amount.
Yeah.
Oh, and then there's the whole issue of structure. So, we mentioned schemas before.
Right.
XML has kind of powerful schema capabilities, but they can also be very complex.
Yeah.
JSON has schema specifications, but it feels like a lot of the time they're not actually used
Right.
in practice.
Yeah, you're right.
Yeah.
And I think often, what ends up happening is that that logic for understanding the data structure and the types is actually baked into the application itself.
Right.
And so that can become a real headache to maintain if the data format changes. And then you have CSV, which, is wonderfully simple, but it essentially has no built-in way to define what each column or row is supposed to mean.
Right.
It's all up to the application that's interpreting it.
It's very implicit. Yeah.
Exactly.
Yeah.
So, imagine adding a new column to a CSV. You might have to update every single piece of software that reads that CSV.
Right.
To handle that change.
Yeah.
And then don't even get me started on trying to handle commas or new lines within a CSV value.
Oh, yeah, that's a mess.
The escaping rules are kind of like the Wild West.
Yeah.
Where different systems do things slightly differently.
Right. So it seems like, JSON, XML, and CSV are great for exchanging data.
Yeah.
Especially when you're talking about, different organizations
Yeah.
where just even agreeing on a common format is kind of a big hurdle.
Exactly.
Right.
Yeah.
But internally, within a single system, especially when you're dealing with maybe very large amounts of data and you really need things to be very fast and very lean,
right.
They might not be the best choice. And that's where I think the idea of binary encoding comes in.
Exactly. Yeah. Within a single organization where you have a lot of control over your technology stack, you can start to optimize for things like how compact the data is on disk or in memory.
Right.
And also how fast you can parse that data.
Right.
And that's really where binary encoding shine, because they essentially try to take that same information that you would represent in JSON or XML, but they represent it in a much more compact and machine-friendly format.
Okay, so let's kind of unpack that a little bit. So essentially what we're saying is that to address these issues with these text-based formats, people have come up with kind of binary versions of JSON and XML.
Exactly.
So for JSON, we have things like MessagePack and BSON and Smile.
Right.
And for XML, we have things like WBXML and FastInfoSet. But I find it interesting that we don't hear about these as much as, they're kind of textual counterparts.
Right. That's a good point.
Yeah.
Yeah, and I think that speaks to, despite the fact that they offer these, potential performance and size benefits.
Right.
None of them have really achieved that same widespread adoption of JSON or XML.
Yeah.
And I think there's various reasons for that. The existing ecosystem, obviously.
Yeah.
And the fact that sometimes it is convenient to have that human readability.
Yeah.
Even though it's not perfect.
It can be helpful for debugging and stuff.
Right, exactly.
Right.
Yeah. But that's what's interesting to note is that a lot of these binary formats, they're still operating on the same fundamental data model as JSON or XML.
Right.
It's still fundamentally key value pairs in objects or, structured documents with elements and attributes.
Right.
They just might have, support for more specific data types,
Right.
Like different sizes of integers or,
Right.
Directly handling binary data without having to do some sort of encoding.
Yeah.
But the core concepts, I think, are fairly similar.
So it's really just a matter of how it's actually represented in the bytes.
Exactly.
Right.
Yeah.
And one thing that I think is interesting about these binary formats is that because they often don't enforce a separate schema,
Right.
they still need to include the names of the fields in the data.
That's right. Yeah.
Yeah.
So, if you have a JSON object with a name and an age field,
Right.
even the binary representation is going to need to store the strings, name and age somewhere.
Yeah.
So that it knows how to reconstruct that object later.
It needs to know what to call the things.
Exactly.
Right.
Yeah.
Now, you mentioned MessagePack before.
Yeah.
And, I think this would be a good opportunity to actually get into the specifics of a binary encoding, because I think, for someone preparing for these senior engineering interviews, that can be really valuable for actually have that deeper knowledge.
Absolutely.
So let's say we have a very simple JSON record.
Okay.
Something that you might see, representing a user profile. So it might have a field called username,
Right.
which is a string.
Okay.
And in this case, the username is Martin. And then we have another field called favorite number,
Okay.
which is a number. And in this case, the favorite number is 3 between 37.
Wow.
And then the last field is interests,
Right.
which is an array of strings. And in this case, the interests are daydreaming and hacking.
Okay. Great.
All right. So very simple
All right. Go.
kind of, JSON object that you might see.
Yeah. Makes sense.
So how does MessagePack take this and encode it into a sequence of raw bytes that a computer can process more efficiently?
So the MessagePack will take that JSON.
Yeah.
And it will encode it into a binary sequence.
Yeah.
So in this particular example, the encoded form is 66 bytes long.
Okay.
And the very first byte is 0 by 83. in hexadecimal.
Okay.
And that's an indicator.
Okay.
The 0x8 part tells us that we're dealing with a MessagePack map.
Okay.
Which is essentially their version of a JSON object.
Gotcha.
And then the 3 tells us that that map contains 3 key value pairs. So right away you get a sense of, the overall structure.
So that first byte tells us we have an object with 3 fields.
Exactly.
Okay. So what comes next?
So then the next byte is 0xA8.
Okay.
And the A here tells us that what follows is a MessagePack fixed string.
Okay.
Which is a short string.
Okay. Yeah.
And the 8 tells us that that string is 8 bytes long.
Gotcha.
And so the next 8 bytes are going to be the ASCII encoding of the string username.
Okay.
And so because we have that length there up front,
right,
the parser knows exactly how many bytes to read.
Makes sense.
And so that's, much more efficient than having to scan for delimiters or closing tags like you would in a text-based format.
Right. It's all very explicit.
Exactly.
Okay. So after the username, we need the value.
Right.
Which is Martin.
Exactly.
So how does MessagePack represent that?
So following the 8 bytes of username, we have the value Martin.
Okay.
And that's represented by a 0xA6.
Okay.
Which again is a fixed. But this time it's 6 bytes long.
Okay.
And the next 6 bytes are the ASCII characters for Martin.
Gotcha. So we're seeing a pattern here.
Again,
exactly.
Right? Yeah.
We have the key and then we have the value, and they both start with this marker that tells us it's a string and how long it is.
That's right.
Okay. So what about the number?
Okay.
So favorite number 1337.
Right.
How does MessagePack handle that?
So after the Martin string, we have the encoding for the favorite number field.
Okay.
And again, that key favorite number itself would be encoded as another length prefixed string.
Right.
Similar to username.
Right.
And then the value 1337 is encoded as a 16-bit unsigned integer.
Okay.
So there's a specific code in MessagePack that indicates a small unsigned integer.
Gotcha.
And if the number fits within a certain range, it can be encoded very efficiently.
Right.
For larger numbers like 1337, it might use a different code indicating a 16-bit or 32-bit integer.
Right.
And then that would be followed by the actual bytes representing that number in binary.
Okay, so this is where the binary format can be more precise.
Exactly.
Because it can distinguish between these different numerical types
That's right.
and sizes.
Yeah.
Right. And then finally, we have the interests field,
Right.
which is an array containing 2 strings, daydreaming and hacking.
Right.
So how's an array like that represented?
So the encoding for interest would start with a byte indicating a MessagePack fix array.
Okay.
And that byte would also tell us the number of elements in the array.
Okay.
Which in this case is 2.
Right.
And then each element of the array, so the strings daydreaming and hacking would be encoded as length prefix strings, just like the keys and the username and Martin values that we saw before.
So very consistent.
Exactly.
Yeah.
It's a very consistent approach.
Right.
And so you can see how MessagePack essentially takes that JSON structure and it breaks it down into a sequence of bytes with very specific markers for the data types and the links.
Right. Now, the intro mentioned that the MessagePack encoding is 66 bytes long.
Right.
Which is not that much smaller than the 81 bytes that the original JSON takes up if you strip out the extra white space.
Yeah, that's a good point. And in this particular example, which is relatively small,
right,
the size difference isn't dramatic.
Right.
But I think that raises an important question. Is that small space saving and the potential speed up in parsing?
Right.
Because you're dealing with binary data directly.
Right.
You don't have to parse text.
Right.
Is that worth the trade-off of losing that human readability that JSON offers?
Right.
Now, for internal systems that might be dealing with millions or even billions of these records every day,
right,
that small saving per record can really add up in terms of bandwidth costs, storage requirements, processing time.
Right.
But, for smaller data sets or in situations where you need to be able to inspect the data directly for debugging,
right,
the trade-off might not be as obvious. And, as we hinted at before, there are even other techniques that we can use sometimes to get even better efficiency.
Right.
But yeah, it's a really interesting question to think about.
Yeah, and it highlights the fact that, choosing the right data encoding format is not just about picking the one that you're most familiar with or the one that's the most popular at the moment.
Right.
It's really about understanding the needs of your application.
Exactly.
And, the trade-offs between things like readability and efficiency, and whether you need things like explicit schema support or, the ability to handle binary data natively.
For sure.
And I think, for someone who's prepping for these senior roles, being able to articulate those trade-offs, I think, is really key.
Absolutely. So yeah, as you're preparing for those technical interviews,
Yeah.
being able to talk about these nuances intelligently,
Right.
and understanding the limitations of these common formats like JSON, XML, and CSV,
Right.
and then being aware of alternatives like these binary encodings,
Right.
and even being able to talk through a specific example like MessagePack, I think will really demonstrate a much deeper understanding of system design principles.
Yeah, than just knowing how to parse some JSON.
Exactly.
Right.
Yeah.
Okay, so to quickly recap our deep dive today,
Okay.
we've looked at the common text-based data encoding formats, JSON, XML, and CSV,
Okay.
and we've highlighted their strengths,
Yeah.
but also some of their limitations,
Yeah.
especially when it comes to things like representing numbers accurately or handling binary data efficiently
Yes.
or managing the structure of the data itself.
For sure.
And then we kind of dipped our toes into the world of binary encodings.
Right.
Using MessagePack as a concrete example,
Yeah.
to see how they try to address some of these limitations by, prioritizing compactness and speed,
Right.
often at the cost of, being easily read by humans. So for those of you who are out there getting ready for those senior level technical interviews,
Yeah. Good luck.
yeah, remember why this stuff matters.
Yeah.
Interviewers are going to often delve into, system design discussions.
For sure.
And this choice of data encoding,
Yep.
it's a fundamental element of that.
Absolutely.
And if you can show that you can think critically about, these underlying technologies
Right.
and really weigh different options
Yeah.
based on the specific requirements, that's a strong signal
Yeah.
that you're ready for that senior role.
Absolutely. It shows that you're not just a code monkey.
Exactly.
You're thinking about the bigger picture.
Yeah.
Yeah.
So to wrap up, here's a final thought for you to consider as you continue your preparation. Given, we have this ever-increasing amount of data that we're dealing with these days,
Right.
and we have all these diverse needs of modern software systems.
For sure.
What do you think the future of data encoding looks like?
Yeah. That's a good question.
Are we going to see, the rise of new formats that strike a better balance between, efficiency, human readability, and robust schema management?
Yeah. I think it's definitely something to keep an eye on.
Yeah.
Yeah. And as you're doing your own research and preparation, I think, that's a good area to dive deeper into.
For sure.
Yeah.
All right. Well, thanks for tuning in.
Thanks for having me.
Yeah.